the first thing I would like to describe, it's we are going to talk about the ASME standard, about gas transmission and distribution piping systems. It's provided by American Society of Mechanical Engineers. And according to this rule, today we are going to calculate such quite simply model, but in this model we have created piping systems with fillet corners, and we are using 3 different shapes for the tubes. As you can see, the circular tube 400, 300 and 350 with thickness 8 millimeters. And we have constrained in this model. It's just a short overview. The model is constrained at the bottom side, at the bottom part, and at 2 points at the top part. And I have already created the ASME Verifier file for this project, and currently we are working with FEMAP, but we can also do this for SimCenter 3D and for ANSYS for sure. And I have already predefined standard ASME B31.8, but as usual we can edit manually by right-click, add ASME, and click the current standard, and we can see that we can see the warning. Actually, it is a beta feature, and you should be careful by checking these results. Press OK, and we can see a lot of different parameters. Actually, ASME calculates a lot for the standard automatically, but there are some parameters which cannot be calculated, and users should define this parameter according to standard. Okay, I have created this standard and press edit, and I have already predefined all the parameters, and I'm going to explain you what is it. The first parameter, it is a pipe boundary condition type. When we go to this button, and we can see the description, which chapter of the standard is it. We can see that the chapter 833.1 restraint, and we can use 2 options, restraint or unrestrained boundary condition. What does it mean? Actually, we can go to the standard. I have prepared the presentation and the screenshot from the standard. It means that restraint boundary condition will take into account different options like straight sections of buried piping, bands, and adjacent piping buried, and different interactions with soil, the deformations of the soil, and etc. When we don't use this restraint, but we use unrestrained, so the calculation will be a bit simplified, and I put a restraint. That's okay, and go to the next one, to the next parameter, pipe internal pressure. It's one of the most valuable parameter for calculation, for pipe calculation, and I have predefined this. Actually, this value means 12 megapascals because we put the value in pascals. Okay. Next parameter, pipe temperature at the time of installation. It also should be typed by the user, and I predefined 15 degree. The next, warmest or coldest pipe operating temperature. Let it be 25 degree. Okay, it means the warmest or coldest pipe operating temperature. When you have the warmest, then the installation time you click the warmest temperature. Let it be 25 degree. And next parameter type E, it is a reference from the standard. What does it mean? Let's look in the presentation. And parameter E, it means the type of the connection when the corners are filled or just chamfered, and when we have some T-joints, different T-joints with surroundings, this parameter should be set according to the standard, according to the table E1. And at the SDC here, we already prepared the classification. What is it? We can see all these parameters here in the tab. And let's plot this, and you can see easily what does it mean. Open the thickness, and you can see that the straight pipe is a blue color, and the welding elbow or pipe bend is a yellow color. And when you would like to change something, when you would like to add some extra element, you can easily do it by clicking plus, add some elements. Let it be this one, for example. Press OK. And we can set the parameter straight pipe. Or we can change this, for example, for welding elbow or pipe bend also. And click apply to selected. We will have one more extra element here, as you can see. And let's move on, press OK. And the next thing, it is out of plane element axis. What does it mean? It means that we have a plane where the pipe is in bending, where the pipe bends, and we have local coordinates of each beam element. I'm going to show you just here in FEMAP, beam y-axis, show y-axis, press OK, and show full model. Actually, we need to change the view, and now we can choose the same operation, show y-axis. And as we can see, y-axis is parallel to the bending plane, and we should choose the z-axis, which will be perpendicular to the bending plane. Actually, in global plane, it is z-x-axis. And we can see that we chose z-axis. Okay, let's go to the next one. Bend radius of welding elbow or pipe bend. For all entities, we predefined 0, and for corners, for fillet corners, we predefined respective values of radius, and we can easily plot it to just short overview. And as we can see here, these elements have radius 0.3 meter, and here we have radius 0.15 meter. It can easily be checked graphically, and move to the next one. Press OK. The next parameter is 1/2 angle between adjacent meter axis. Actually, it is a parameter also from standard, but this parameter can be calculated by SDC automatically based on previous couple of parameters, and you don't have to set this parameter. We just can click 0, and when this parameter equals to 0, we have this notification. If not required for calculation, should be equal to 0. It means that program will calculate this parameter automatically. Let's press OK. Meter spacing, we have the same option. We can just put 0, and this parameter will be calculated. The next thing is a location class. Location class, it is it should be applied according to the table from the check, from the standard ASME, and I'm going to show you this in the presentation. Location class, we have actually 4 classes, and first class has 2 divisions, and choosing this parameter, we will change the design factor F. Okay, for our demo presentation, let it be location class 1 division 1. Okay, and the next thing is the temperature. The thing is also from the parameter table 441.1.8, and I'm going to show you this. Temperature, it means we choose this here, the classification, and we will have some reduction factor automatically applied in SDC verifier. Actually, I chose 300 and press OK. Pad or saddle thickness. This parameter can be also calculated automatically by SDC. And let's press OK and move on. And radius of curvature. This parameter also can be calculated by SDC, and actually all these parameters I put 0 just to show how it works, and that no need to fill in all of these parameters because it looks a bit like huge amount of these parameters and a big amount of work. But don't worry about it, because it can be simplified by using default parameters, which will be calculated automatically. And at this side, at the left side, the last parameter, it is a coefficient of thermal expansion. Actually, it is a standard coefficient of thermal expansions. We use this for steel, and this value can be from 10.8 to 12.5 multiplied by 10⁻⁶. And okay. The next parameters which can be set in this check ASME, load factor, A parameters, and here we have the description of this parameter. For long duration loads, key equals to 0.9, and short duration key equals to 1. Actually, we have one load, working conditions, and we assume that this load has a long duration, and press OK. But when you will have the different loads with short duration, this parameter should be equal to 1. Okay, move to the next one, longitudinal joint factor. According to table 441.8-2018, define, and all entities 1. I'm going to show you about this here at the presentation. It means the classification of the joint. When it is seamless, this factor will be equal to 1, but when this connection will be electric fusion welded, for example, class 13 or 23 or etc., this factor will be equal for 0.8, and it also should be taken into account as well. Next parameter, out of plane stress intensification factor. This parameter also from standard, but we can set 0, and the SDC will be calculating this parameter automatically, as well as the in-plane stress intensification factor. So actually we have 2 stresses for this parameter in plane and out of plane stress, and press OK. And we can also use our own design factor. And for we can define this actually by putting a mouse here. We can see the detailed description. And the next thing, for calculating the check, we need to apply yield and tensile stress for the material. Actually, materials with yield and tensile equals to 0, 0, because I have defined this. But while creating new project, we will need to put some values here and press set. It will be automatically filled in all these parameters, yield and tensile. Press OK. And actually, we have created the ASME standard parameters, and we can press OK. By expanding this parameter, we can see the input, the characteristics, which we can change here, right click and edit, and it also can be edited just by editing the standard and editing this parameter one by one. I think it's more suitable, and we don't have to fill in classifications. No need to do this. And we have here one check, designed for longitudinal stress. It means based on all these parameters and based on the finite element model, we will the SDC will be calculating the design longitudinal stress and will be calculate the utilization factor for ASME B31.8. And I have predefined the plot. We can just preview this plot in FEMAP, and we can see the results. We can see that these tubes with the biggest radius have the values quite to 1, something between 0.9 and between 1. And we can also create the table, components table, to see the to see it more in detail, and add selection, properties from list. Actually, we have 3 properties here, as I showed you at the beginning. Press all, OK, and let's fill this table. Now we can see all the parameters which are used and which are calculated automatically by SDC verifier for each property. The same thing we can do for each element or for each material. It's up to you. And as we can see, that the biggest utilization factor 0.93 and the lowest is 0.69. And also we can see all the parameters, especially nominal bending stress, which occurs in these elements, which also has influence of the calculation. And let's press OK. And so we added the plot, we added the detailed table for this check. And when you would like to add this for your report, you just can easily add the report by adding and let it be designer results. And you can add all of this information about you can add your plot, add your table to the report, and it can be easily presented for your customer. And when something changes, the report will be regenerated. You can regenerate report automatically. And it was the short overview of ASME standard. And thanks for your attention. It was my pleasure to prepare you this overview. And I would like to take a word for Oleg.
Yeah. Thank you. Thanks a lot. Very extensive and detailed presentation of the new standard, Vitaly. This is a piping check, something new that we haven't had in SDC Verifier before. So for those who are using the pipe checks in their engineering routine, I believe it was very extensive and important to have this. If you will have any comments on this particular code after you try using that or even before, let us know. We are happy to hear that. There was an option to set the warmest or coldest pipe operating temperature in the wizard of your standard, but
Yes.
what to do if we have both, if we have the installation temperature and then sometimes it's warmer, sometimes it's colder. I'm not sure if that's the case for the standards and for operational conditions, but probably it is possible. What do we do in that case?
Well, you mean that the operating temperature will be higher and bigger and lower also.
Yeah, if we have both
The
conditions, very
okay.
warm
It,
and very cold.
okay, in this case, we need to create two checks, but for simplification, we can copy the previous check with defined parameters, and there we can define the warmest at the first one, for example, and the second check we can put the lowest, and we should to calculate both of them and compare the results and choose the worst case for this.